Hello everyone and welcome to today's webinar, Kubernetes and Zero Trust Security, supporting a CARTA approach to anomaly detection. I am pleased to introduce today's speaker, who is Christopher Liljenstolpe. He is the original architect behind Tigera's project Calico, the de facto standard for Kubernetes network security and compliance. He speaks at over 60 meetups every year, educating people on networking and network security for modern microservice-based containerized applications. He consults Tigera's enterprise clients also on their security and compliance as they take their applications to Kubernetes and to microservices. Before I hand this webinar over to Christopher, I have a few housekeeping items I would like to cover on this presentation and the webinar platform. First, today's webinar will be available on demand immediately after the live session. It'll be accessible through the same link that you are using now. We will reach out to you with slides and everything after this webinar, and we'd love to hear from you, most importantly, during today's presentation. So if you have a question, please feel free to ask those questions in the question interface on BrightTalk, and we will get to them. We'd like to do them in real time as much as possible. That way the flow kind of works. And but we will reserve time at the end for a more general Q&A and to take any last questions you might have or any questions we didn't get to. So, without further ado, let me hand it over to Christopher. Christopher?
Thanks, Michael. So, again, we've been talking a little bit about the CARTA model in the last couple of meetups, the last couple of webinars. So that was a slip. Last couple of webinars, and I think maybe makes a little sense just to remind folks who may not have been attending these webinars before. Basically, CARTA is a model, and I don't think this is unique to Gartner. Gartner sort of badged this as CARTA, but this is a DevSecOps model to zero trust network security. So if you think about the standard DevOps model, that's sort of the bottom of this inverted T, where you've got develop, and develop turns into test, evaluate, deploy, take feedback from that, take that and feed that back into the development process as an iterative cycle. When you throw security into the mix, then there's a number of other things you need to be taking into consideration, such as analyzing your current threat environment, looking at risks, risk posture, etc., exposures, and that also becomes a set of introspection that you then use to inform your development and deployment. So this is sort of a DevSecOps cycle, and it's Gartner at least is calling this CARTA, but really this is how do you do DevSecOps in a zero trust environment. So we think we've talked about policy enforcement, we've talked about monitoring and alerting, and those are all necessary. But as we become more dynamic in our environment and the threat environment becomes more complicated and more congested, we really need to start thinking about how do we detect the anomalies that we don't know we're looking for. So monitoring and alerting are great for telling us things that we knew might go wrong have indeed gone wrong. But how do we know if something's going wrong that we didn't know to look for? We didn't notice how to to set a trigger for a specific kind of event. And you can still be pretty good at pre-setting triggers, but you probably need to start thinking about how do I detect anomalous behavior in my infrastructure, something I may not have even been thinking about as a potential anomaly. So that's what we're going to sort of talk a little bit today. Is how does anomaly detection or machine learning fit into this kind of model? So why don't we continue on with the process? So Kubernetes, by nature, or any cloud-native environment, is much, much more dynamic and has much more in the way of moving parts than your previous VM kind of environments or static environments, right? The whole idea here is you're decomposing large monolithic applications to a much larger set of simpler building block components that get remixed and reused in different ways. And you're iterating through those much faster. You know, one of the key drivers for adopting this technology isn't only ease of software maintenance, but ease of rapid development. You know, you want to be more responsive to market requirements, etc. So you're going to be pushing code more frequently. You're going to be making changes to the infrastructure more frequently. We covered some of the impacts these have on policy enforcement. That static policy enforcement based on IP addresses and static identifiers is problematic in this kind of environment. We've talked a bit how compliance and monitoring become a cropper when you do this. If you're doing compliance auditing and you do that a couple times a year and you're changing your infrastructure multiple times a day potentially, is that compliance audit still valid? So you really need sort of a continual compliance environment. Similarly, you know, so that's similar. That's sort of the environment we're in. So this, you know, it's a large data set. There's a lot more endpoints potentially in some cases, hundreds of thousands of endpoints in your infrastructure in a very large containerized environment, and it's much more dynamic, and there's a lot more interdependencies in the graph than there were before. Things that were all contained within a given compiled image are now spread across lots of microservices. So it's a complex and large infrastructure that is also undergoing dynamic change. It's very rapidly mutating, so it becomes more of a challenge to detect malicious activities, especially, you know, taking forms 0 days that you weren't even looking for, right? So you probably need to start detecting and trying to baseline what is normal, and then at least flagging things that no longer look that don't look normal. So, you know, what you need to start being able to do is, for example, pick out protocol deviations. You know, normally, you know, clients calling the customer database environment normally make, you know, n number of calls and a cadence of a certain frequency and a certain number of hits for a given transaction, and all of a sudden that changes dramatically. Now that might be your code changed, or it may be something else changed. Reconnaissance activities, looking for people probing. And again, in a zero trust environment, we assume that we will have threats in our environment. We're going to assume that people get workloads into our environment that are malicious. And one of the key early landing beachheads in this kind of environment is what's called reconnaissance activity. It's basically someone gets a workload into your infrastructure and they use that workload to map out where resources are, where the interesting bits of data they might want to exfiltrate are, or the things that they want to target to change. And again, volumetric deviations, things like DOS attacks. You know, all of a sudden are certain things much more talkative, either external or internal to your fabric than they were before, and then you make a determination if that's valid or if that's invalid behavior. So those are some of the anomalies that you might want to be looking for, and again, in a very dynamic environment, it might help to actually have some automatic detection of these anomalies. And I think Michael said it, but just in case he didn't, you know, this is, you know, feel free to ask questions as we go, and you know, I'll try and answer them as we go. Otherwise, we'll answer them at the end. So, you know, a quick review of policy. You know, policy in Kubernetes and Tigera's solutions specifically is based on intent. So, and this is pretty key also for anomaly detection. If you start thinking about the amount of flows that are happening in the infrastructure, if you don't have some way of classifying those flows, it becomes very, very problematic to do any kind of anomaly detection, or even just standard logging, alerting, monitoring, etc. It's just a huge morass of data. So you need to start classifying traffic And the way that's done in Kubernetes and with Tigera solutions is by an intent-based policy. Things labeled Bob can talk to things labeled Alice on 443, or things that are only things that are labeled PCI compliant can contact a database that is contaminated with PCI data on 8080. Things labeled customer database, customer front end can talk to things labeled customer database server, but only on 443 and only make HTTP gets to cust record URI prefixes. So you have these kind of policies that have defined the intent. It doesn't matter how many of those things there are, how many of those labeled things there are, if that traffic happens or not, but there's an intent-based policy model. So we can do that. We can then write guardrails and say those are the only things allowed, everything else is denied. Standard least privilege or zero trust model. But even if something is allowed, so we now have traffic that is allowed that matches that requirement, we may want to detect and see if that becomes anomalous, that allowed traffic becomes anomalous. And we've covered this in some of our previous blogs and webinars. Please feel free to go back and look at the blogs and the previous webinars in the series, and we'll cover this in greater detail. So, monitoring, if I take a look and think about Gen 1 in this space of monitoring and alerting, we log this on 5 tuples. We log this on IP source and dest, IP port, source port and dest, and protocol. That's not really all that useful since IP addresses are very ephemeral in a Kubernetes environment. So that form of logging is not really all that useful. Corollary of that, if that's not really useful for logging, using 5 tuple for anomaly detection is also pretty useless. It's hard for me to detect anomalies if I'm doing that based on IP addresses, when IP addresses might be ephemeral and the same IP address might be assigned to 5 very different workloads, for example, in the course of a day in a Kubernetes environment. So anomaly detection based on IP address is a fallacious environment, a fallacious assumption, just like it is for standard logging and monitoring. Gen 2, we can start taking metadata that's associated with these workloads, and we can use that metadata to enhance our logging and monitoring. We can say, I don't care really, we can capture the IP addresses certainly, but what I'm really interested in is what was the thing that tried to make this connection that was allowed or disallowed by policy. It was labeled a customer database server, okay, or it was labeled PCI compliant, or it wasn't. So I now can start collecting real metadata. What was the actual container or pod that did this? And that's traceable back to the CI/CD pipeline and eventually the source code repository, and I can actually figure out what that thing actually is, who launched it, who wrote it, etc. So I have a lot more data available to me by monitoring and alerting based on metadata. That same metadata can inform anomaly detection, automated anomaly detection. We'll talk about that in a minute. So basically, the generation we're talking about, this has got to be metadata based. It's got to be based on sources of truth that are more reliable than a simple 5 tuple. Information that comes out of the source code repository, things that come out of the CI/CD pipeline, things that come out of the actual orchestrator itself, even the behaviors and the certificates that are associated with various objects. So, visibility and traceability. I can look at things like denied packet metrics. I can see patterns. Gee, all of a sudden I'm getting a lot more denied packets from a given set of containers. Why is that? Did somebody screw up a policy? Did someone not screw up a policy? I can start looking by eye for patterns. So if I know of a pattern, I want to look and see this is sort of an anomalous behavior. Why did this the number of packets here, denied packets, drop off substantially, and then spike back up. So I can posit an idea, I can go research that, but this is anomaly detection. It's anomaly detection by human, and the only way you're going to get this is if you actually knew to graph this or some other representation where you could visually see this and go, oh, that's anomalous. I want to go figure out why. So this is anomaly detection, but it's anomaly detection of anomalies I was suspecting I might see. I can set alerts and alarms, etc. But what about all those anomalies that I haven't assumed that I might see? Or, frankly, there are so many different anomalies that I may be interested in that I can't really have graphs for all of them, because otherwise it becomes a manageable list. It's the overload of data to go through and look at all this stuff is too difficult, too large. So maybe what I actually need to do is start using some machine learning and start trying to pick out these anomalies even if I wasn't actively looking for them. So, here is, in a Kubernetes environment, I've got master nodes, I've got worker nodes, or applications, or Kubernetes infrastructure on these. All of these things in a Tigera environment or a Project Calico environment have policies applied to the network traffic. So I'm already classifying traffic. I'm only kubelets on worker nodes are allowed to talk to etcd on master nodes. Only customer service front ends can talk to customer database back ends. So I have all these policies already. That's all of those flows that are allowed or denied are being captured. And in Tigera's solution are being stored away in a EFK stack or some other stack, but by default an Elastic Fluentd Kibana stack. So we're already capturing that data. And that's when you look at some of the earlier webinars we've done and blogs, we talk about being able to visualize all the flows and look at all the alerting, etc. That's coming off of that EFK stack and off of a Prometheus time series database. Once I have all that data classified and it's all in a searchable store, then I can start doing things like machine learning. And this is a new feature that's been being added as we speak to Tigera's solution, where we will actually run machine learning detectors and model builders across that data store. So we can now take and say, I want to look at drop packets, or I want to look at number of connections coming off of every pod, classify those or count those based on the labels on that pod or the names of that pod, i.e. what Kubernetes deployment it came off of, and then look for anomalies. Almost all things, almost all deployments have no more than this number of connections to different endpoints opening a minute, but this one has this deployment has a huge spike in number of connections per minute to random endpoints. And the previous generation of this deployment didn't. Okay, well maybe I now have a deployment that's been co-opted by a reconnaissance platform. Or one instance of this deployment is doing things very anomalously different from all the other instances of a given deployment. Again, indication maybe I've had a compromise of an actual pod. But by doing this and having these detectors, I can actually be looking for patterns without actually knowing what patterns I want to look for. I'm just looking for patterns in general, and the system can call out things that are not matching the statistical norm that I would expect to be seeing. So we can get alerting from this. We can get, there's anomalous behavior alerts. If I want to extend this even further, I could even drive automation. I could say, for certain types of anomalous behavior I'm looking for, I can say, what, that crosses some threshold. It's definitely very anomalous. High degree of confidence that this is some form of compromise. So maybe automatically I actually quarantine the traffic. We've talked before about automatic quarantines using labels in Kubernetes, again, both in blogs and webinars earlier in the series. So you could actually have anomalous detection trigger actual events. Like this deployment is, a new version of this deployment is just pounding the heck out of anything that's labeled confidential data as a detector. And so at some point, or some form of confidential data. So based on this, I'm just going to automatically fire off a quarantine on that deployment until I get a better look at it. Or you can raise an alert and have somebody manually intervene and decide if they're going to quarantine it or not. But the key thing here is it is the machine learning environment that's picking up the anomalies rather than you having to know to go look for that specific kind of anomaly. So so if you look at the anomaly environment, I'm going to try and make this slide a bit bigger. Unfortunately, my screen makes this very small, and it's hard for me to read so many things. But from a given anomaly, I can actually deep dive into the details. So I get an anomaly report. I can actually dive into that. I can see what labels were attached to things, what endpoints were involved in this. And I can get all the metadata and rich data as to why this anomaly was detected, what was anomalous, all the components of it, and I can analyze. Is this is this something that requires me to go in and do deeper analysis, or it's okay, or it's, I just need to get this off my network. So because we collect such rich amount of data around all of these flows, we can actually make have a very informed set of anomaly detections, give you all the context around that you need in order to make a decision on what you want to do going forward. So we can then visualize this as well, and we can then start attaching risk profiles to things. So you can actually see that for given endpoints, given anomalies detected, I can actually rank them by risk level, by timeline, etc. So I have a very broad, easily visible dashboards that will allow me to pick up anomalies, decide which ones I need to look at now and which ones I can delay. These are all things that are there in the product today, and we're extending. As I said earlier, anomaly detection just based on IP address is pretty problematic in a Kubernetes environment because that IP address is always ephemeral. You really need to tie this to the deployment, to the labels. You might have 20 different deployments that all contain something that is a customer database client. So what's interesting is not the IP addresses, because those are changing frequently, but what is the normal statistical behavior of all the things that are customer database clients. And if all of a sudden all of them statistically behave sort of similarly and all of a sudden one deployment doesn't, then maybe I have an issue. So in order to make this really informed, you need to work off the metadata and use some metadata to inform your anomaly detection, not just simple endpoints, because those endpoints are short-lived and ephemeral. I keep on banging on that, but that's a really important message. You need to be careful about learning around these environments because you might be learning bad habits. So again, you have a better chance of filtering out bad habits or bad behaviors out of your model by, again, using things that are using modeling based on the expected behaviors, i.e. what's in the metadata, rather than actual behaviors. So all the things, like I said, they're customer database clients. I can build a statistical model of what that looks like, and even if I have a bad actor in my network, it's more likely I'll pick it up than just learn that as part of my model. So learning models without putting context around it that's actually meaningful is you can actually learn bad behavior. Secondly, what do we do when, so there's anomaly around, dropped packets, attempts to connect, etc. There's another set of analysis called traffic analysis that you can start doing, and this is something carriers have been doing for a while on their networks, and definitely the intelligence community has done for a long time in signals intelligence, which is traffic analysis. Instead of just looking at what ports or what protocols are being used and trying to decide if this is anomalous, you can actually look at the traffic patterns of a given flow. Again, from an anomaly behavior, this is stuff that, we're just beginning. These are things that, we need to explore and enhance in anomaly detection in this industry going forward. But if I know, for example, that this application makes a call to this application, and the packet cadence, the way the two interact, meets a certain pattern, and all of a sudden the cadence changes, is that an indicator that I've had a change and this isn't really a normal client, it's doing something else? So this isn't even just based on number of connections, etc. This could be even inter-packet arrival times. Normally this thing has this cadence and the cadence changes. That can be an anomaly. It's called traffic analysis. Volume of traffic changes, etc. When we start integrating application layer policy information to ML, we get even higher definitions. So Tigera's solutions offer policy all the way up through layer 7, so we can actually analyze not only the protocol port, endpoints, etc. We can actually say for some things like HTTP and gRPC, we can say they actually went to this URI, or they tried to do a post or a get to this kind of object. As more and more of that data gets surfaced in these logs, we're already doing those controls. As more and more of that data gets surfaced in these logs in this data store, we'll be able to do machine learning and anomaly detection across that as well. So all of a sudden, the anomaly detection is the endpoint is using the same protocol and port it's always used before at the same cadence, and it's connecting to the same endpoints as a foreign endpoint, but all of a sudden it's asking for different objects rather than the objects it's always asked for before. That's an anomaly. So now I can actually start doing anomaly detection within the application flow, not just within the network flow. That's a really interesting capability. The way we do application control is in Tigera, we're actually doing this within the sidecar that's actually putting together the application flow, in case of Istio, which means that we can actually do this before the packet leaves the pod, but also before the packet gets TLS encrypted. And the TLS encryption happens before you leave the pod, but we're doing this earlier in the chain than the TLS chain, so I can actually see what's going on in the packet, but I'm doing it within the security confines of the pod. I don't have to make a man-in-the-middle attack, which is basically what middle box proxies, TLS proxies do. I'm stopping the encryption, I'm re-exposing the packet in a shared environment, and then re-encrypting it and sending it on its way. In the case where we do it, we're doing it within the pod, so within the security boundary of the pod. Once it leaves the pod, it's encrypted till its destination. Much harder to man in the middle, but because of where we do our application policy control, and therefore where we collect our data, we can do that before the packet is encrypted. So the opacity of TLS is less of an issue for doing machine learning on application policy in a Tigera environment. One of the other things here is, because Tigera's scope is not just your Kubernetes cluster, but it's your bare metal, adjunct services, even IP address ranges, etc., are all considered part of a set of endpoints where we have metadata and labels associated with them. I can actually make sure that this metadata machine learning anomaly detection environment encompasses all of the things that integrate with your Kubernetes or your cloud native cluster, and including VMs, bare metal, etc., rather than just within the scope of the cluster. So these are some of the things where we're extending this capability. This is early on in the capabilities that we are building. But I think some of the key takeaways here are there are other people doing machine learning. You have to make sure your machine learning is based on real metadata that actually defines the expected behaviors and is durable in the long term as far as an identifier that you could map a behavior to. You need to be able to do this across all the layers of the stack. You need to avoid TLS opacity. You need to start thinking about things like traffic analysis or traffic pattern analysis as well. So with that, this is sort of a brief introduction, but the key takeaways. You cannot purely rely on machine learning. One of the advantages of an intent-based policy is because you're in a least privilege, many of the threats can be reduced simply by having the developers and the compliance team and the security team define what is allowable. All of a sudden takes off the table all of the things that aren't allowable, all the possible connection paths that don't have actual utility in your infrastructure already closed down. So that's a huge win. We now have driven the attacker into a smaller subset of channels. Those subset of channels we can then monitor and alert on, and that's great, but we can now also start doing machine learning model building to say, for this kind of channel, things that are customer DB clients behave this way when they talk to customer DB servers. And we can build a model on that, so that when that changes, or even when I'm building the model, I have a statistically substantial signal saying this is normal behavior, and I have this outlier. I can even pick out, now with this scoped environment, I can even pick out the outliers when I'm building the model. So I don't build a model based on bogus or attacker data. But now that it's all scoped, it makes it easier to run anomaly detection across this to automatically pick up on patterns where somebody has gotten into this fabric, is capitalizing on the paths that are available that are necessary to be available for your infrastructure to work, but I can still pick up the anomalies when they start trying to change the behavior subtly of those flows. So with that, it's an introduction to anomaly detection in a CARTA or DevSecOps environment in a dynamic environment like a containerized or Kubernetes environment. So with that, I don't see any questions, and I'm going to turn it back over to Mike.
Yep.
So Michael,
hey,
do we have any questions that you can see?
Yeah, no, well, we don't have any questions at the moment, but while we are waiting for questions, I think it's pretty obvious with this slide up that we'd like to talk about the next webinar we have coming up in 2 weeks around Istio traffic management and Kubernetes security and all those things that fit together. I know Istio is a burning topic among most of our customers. Everybody has an Istio plan, even if they don't know what Istio fully is. So I think it'd be great for you guys to tune in for that one. And also, we had a past webinar with AWS and Atlassian. It talks about Atlassian as a case study around their journey from a monolithic application to the cloud and microservices, multi-tenant, and secure using Tigera and compliant. So those are two great webinars. Of course, we have all the webinars on our Bright Talk channel. And so without any further ado, without any questions, I would like to thank you all for attending, and we will see you next time. Thank you.
Thank you very much, everyone.